Hello friends, today I will bring to you a module which can control a garden remotely. It will pump water for the vegetable, also monitor soil moisture, temperature, humidity, UV from the sun. The LoRa module is connected to computer, compared with software to get data from the remote module. The LoRa module will help us to communicate with the remote module in range longer than Wi-Fi and more stable. I will open the pump to let water out. We can see value of moisture has changed. The software also displays the value of garden, such as UV from the sun, humidity, and temperature. At first, we will see how the circuit works before going to the code section. The LoRa module is connected to Arduino by serial line to communicate with computer. If you don't have LoRa module, you can connect the Arduino directly to computer by COM port to test the program. Next, we will connect humidity and temperature sensor by I2C communication. And of course, the important sensor for our garden is soil moisture sensor. The sensor rod will be installed to soil to measure moisture. It will help us to decide when to supply water for the garden. And here is the pump controlled by H-bridge. Overall, the module looks like this. In the computer section, we only use a USB to COM port converter to communicate with a remote module by another LoRa module. We will design an HMI to get data of the garden and also control the pump. Now, we will move to the code section in which I will guide step by step for even newbie can do it. Firstly, we make a new project at Arduino to see how a command line sends to a computer. We will have Arduino connected to computer by COM port 9 and LoRa connected to computer by COM port 5. Then Arduino sends a sample line to the computer. Remember, COM port 9 of Arduino is used for programming only, while COM port 5 is for LoRa to get data from a remote module. Okay, we make a figure for zero speed of the LoRa, which is connected to the Arduino. This speed is configured for LoRa in the previous video. Making command string to send the computer. I will try to make a sample command hello friend. Next, we make a command as LoRa structure which has 3 sections: the header, the length, and the content of the command. Then output the command to LoRa by serial communication. We should add delay to prevent overwhelming data for LoRa. We will choose COM9 to download the code for Arduino. Remember, when downloading the code for Arduino, we should take out the serial cable of LoRa out of Arduino, because Arduino also uses a serial line to upload the code from the computer. Open COM9 of Arduino. We will see command from Arduino sending to computer. We just open COM9 to see what happened inside Arduino. Then we close it to open COM5 of LoRa on computer side. Also, we should connect LoRa on Arduino to allow it send data to computer. Here is the result on LoRa on the computer side, which is sent from Arduino. Now is Visual Studio Code. We make new project for Windows Form application. As we see here, it is application for Visual View. Left side is Toolbox, the right side is the property of each tool. Right-click to view the code. We will compile the blank project. No error, nothing else. Good start for us. In the Arduino section, it will repeatedly send the hello command, and now our progress is showing the hello command on the Windows application. We will find the serial port tool, drag it into the project, copy baud rate of LoRa module into properties of serial port, and also rename port name into COM5. Next, we will take timer for the project. Purpose of the timer is to tick every interval time to show data value. Right-click into the Form 1, View Code. We will go to the code section when the Form 1 is loaded. It means when we open the application, this code will run one time, and firstly, the timer 1 should be started here, also for the COM port. We will make global variable for string garden to store commands from Arduino. and we put it into nothing when the form is loaded. Compile the project to see any error. Nothing. Perfect. Now, we return to the serial port. In the Properties toolbar, we choose the Event tab and double-click into the data received. We will move to the data received section of the serial port. It means when data is received in the serial port, the code section will run. Of course, here we will store data into string garden. We will need a label to show data result. Pick up the label, drag it into the form. In the properties, we see the content of the label at here and name of the label at here. Let's change the content into data received. This label is for naming only. We will need another label to show the result of the data from the COM port. No need to change the content of the label. Now, we need timer tick event to show data. This timer is set interval every 100 milliseconds. You can set it into another value. Choose event, double-click into tick. We will go to the tick event code section. Show data label 2. Try to run program. Voila! Data as shown. We come back to Arduino code to get data from the sensors and send them to computer by LoRa, making configure for humid and temperature sensor BME, then UV sensor, and finally the soil moisture sensor. This section is for sensor BME declaration. We will go to the loop section to get data from UV sensor. It is saved to UV value. Though serial print line group code is just for troubleshooting only when we want to show value to the serial monitor. Remember, the UV value variable is declared here. Next, we will do the same to get data for soil moisture, also same for BME sensor, where we will get humidity and temperature data. I've just forgotten the important thing. We must begin the I2C network for BME sensor when we start running the code. Return to the loop section and uncomment the serial print line group to see the result on serial monitor. Compile, download, and we got data here for UV, soil moisture, and temperature. I forgot to show the humidity value. We will go back to the code to show humidity value. Let's try to download again, and it's here for humidity value. Okay, as I said before, those shown data is for troubleshooting only, not data to send by LoRa to the computer for visual code, so we will comment on them again. In order to send those values from the sensors by LoRa, we must use the LoRa structure as previous sample for the hello friend command. We will give a blank for transmit variable to clear any unwanted value. Then we add UV value with the mark UV in front of the UV value, and we add a dash to distinguish it from another value. By this structure, we will do the same for soil moisture value, humidity value, temperature value. We will give a forward slash to end the command. All the sensor data is sent by LoRa structure. Download the code to Arduino. We see the value of the sensor is sent by LoRa structure with our way to distinguish each value. Visual code will get this kind of data structure and have to extract value to each type sensor. We return to Visual Studio Code and run the program to check what data it gets. It is exactly data structure we made in the Arduino code. Because the window is quite narrow, I will drag it wider to show all data. Let's check it again. It can show all data on the window. We take the label to indicate the value data and name of each sensor. Remember, we must remember the label name of each type sensor. For example, label number 4 is for UV sensor, and label number 6 is for soil moisture sensor. Now, our next mission is to extract value to the equivalent sensor and show on the window for user view. We will use the timer tick event to update real-time data. I will return to Arduino to get data structure and put it here for easy view. First, we will check if the guidance string data is suitable to extract value. If yes, we will search for the U letter. Then, we will check if it is UV. If yes, we will get the value until the dash and show it on the label number 4. Let's run the program to check the code. So far so good. The value of the UV sensor is extracted exactly. So we will do the same way for soil moisture value, and then humid value, and then temperature value. Now, we turn to the section making button to control the pump. We will make buttons for the run command. Double-click on the button to go to the code section of the button click event. It means when the button is clicked, this code section will run. When the button is clicked, we will send a command to Arduino about turning on the pump by this command structure. I will return to Windows to change the indication of the button into on. Then make another button for stop. Again, double-click on the button to accept the click event and send command to Arduino to stop the pump. Let's compile the program to see if there is any error for new code. Nothing. We return to the Arduino code section, declare variable for pump input and LED lamp on Arduino board. Stop the pump when the Arduino restarts. We will put this code to receive command from Visual Studio and save it into string command receive. Of course, we have to declare it at the top. We will extract the pump command from the string command receive. This code will search for PM and save the afterward value to the variable temporary command pump. The command pump then feeds back to Visual Studio to inform the status of the pump for user. I will put a comment here. When the command PM on means turn on the pump, and PM off means turn off the pump. We should declare the variable command pump at the top. We also delete this delay time. We return to Visual Studio to run the program. Click on the pump. We will see the Arduino code feedback status on of the pump. Click off the pump, and we see status off of the pump. Return to the code section to extract on status, and show color red if the pump is running. The same way, show color green if the pump is stopped. The color indication works fine now. At Arduino code, we will update pump and LED status based on the variable command pump. I will test it with the LED on PCB Arduino UNO. I just forgot one thing. We should make sure to stop the pump when the code starts running, so we put the variable command pump to off here. Okay, the code at Arduino and Visual Studio basically works perfectly together. After we finish making the code running functionally as our purpose, we will make visual screen for user easy view. We insert picture for each type of sensor like this. Firstly, go to the Google to search for images. For example, type in UV icon, then choose the PNG picture, which doesn't have background. It means the background looks like checkered pattern, then save it somewhere. We will do the same way to get picture for moisture, humidity, and temperature. Return to Visual Studio. We use the picture box to insert the picture we got. We will choose the UV picture and select size mode zoom. Do the same way for moisture, humidity, and temperature. I will insert the pump picture here and then make arrangement for all. Let's run the code. On off the pump. The status of pump is also updated by color red and green. Value of each sensor is updated in real time. The last thing in this project is using a combo box to select COM port. We will make a list from COM1 to COM10 for user selecting. Double-click on the combo box to access the code when a port is selected. We will update COM port name by selected port, then open the port. Of course, we should not open it when the window is loaded. Let's check it. It can run normally. However, when we choose a COM port which doesn't exist, it will issue an error. Then we will use the try and catch function to prevent unwanted issues. Using this line code to close the port, which was open before, I will open COM1. No error. But when we click on the pump, the error line will rise. So I will use the try and catch function when we click on the pump. Test it, and no error anymore. Do it the same when we click off the pump, and test it with non-existent COM port. And with COM port 5, the program runs smoothly without error. We will make the execute file for a project by choosing Release here, and compile normally, then come to the folder of the project. We will see the execute file which is ready for using. I hope this video can help you to be confident to make an HMI by Visual Studio and communicate with Arduino. Don't forget to subscribe my channel and share this video for those who need it. Thank you.